All right, good morning, everyone. It is 8 o'clock, so we'll go ahead and get started. So this is the final week. You have a few more days left in this class. The last day of the class will be Tuesday, which is in like 3 more days or so. So a couple notes before we get started is Tuesday at 11:59 p.m. Eastern Standard Time is the last moment that I can take any assignment to be submitted. So there is the policy, and I put it out several times before, is that if you've done poorly on a past assignment, you can correct your mistakes and have it resubmitted to be graded again. That the late penalties will apply to that. But if you did poorly, you can, of course, fix your mistakes, resubmit it, and there's a pretty good chance you can improve your score. Now, with this current assignment that you have due, there is no turning it in late. Period. That's as clear as I can make it. There is no late turn in of this assignment. The current due date of 11:59 p.m. Eastern Standard Time on Tuesday is the last second that you will have to submit the assignment. If you try to email it to me after that period, it's incredibly unlikely that it will be accepted. So please make sure you get it submitted before that time. I highly recommend that you don't wait until 11:58 to try to submit it, because maybe something goes wrong and maybe your browser crashes or something. I don't know. There's a million reasons that may interrupt your ability to upload your assignment. So please make sure you try to get it in before the last minute. Okay. And of course, between now and then, if you're struggling with it or if you have any questions, please get in touch with me. The best way to do that is send me an email, attach your Java code to that email, and ask a specific question. If you just ask a generic question like, my program doesn't work, that's not very useful. I'm not going to tell you how to do the entire assignment. But however, if you send me an email and you attach your code and your question is more like, I'm trying to print out this array, but it prints null values too, that's a more targeted question that's a lot easier to help you with. So please, when you ask for assistance, ask very targeted questions about the specific problem about the specific thing you're having a problem with. Okay, so on to the material for this week. So this week is all about classes and object-oriented programming. So object-oriented programming has actually been around for a long time, since sometime in the early 80s or so, I think, is when object-oriented programming first started coming around. And what object-oriented programming means is that you try to treat your code as if it were real-world physical objects. And what I mean by that is, let's say you're making something about a car. And you'll see throughout this morning, our theme and our example is going to be based on cars. So if you think about a car is a real world physical object, right? And it has certain properties, right? It has a color, it has the make, the model, how many miles does it have on it, how many gallons of gas are in it, what's its miles per gallon, what kind of stereo system it has in it, what kind of interior it has in it. Those are all properties that describe a car, right? And also, there are actions that you can do with a car, right? You can drive a car, and these will be mainly verbs, right? You can drive a car. You can fill up the gas tank. You can change the tires. You can change the oil. You can recline your seat. These are all kind of action type things you can do with a car. So the concept of object-oriented programming is, if you want to have some software that models a car, that represents a car, maybe you're making a program to run a car dealership. Maybe you're making the software for a car dealership, and you need a way to represent each car that's on your lot so that you can sell the car and so on and so forth, all these other things you can do with the car. So when you're designing your software, you will make an object that represents that car. And that object will have all of those properties. Yeah, you should be hearing me. I see a chat message. You should be hearing me, Anthony. Can anyone else not hear me? Or if I can get someone to type in that they can hear me. Okay, it must just be your audio, Anthony. So just check your settings. And of course, the video will be posted. So if there's anything you didn't hear the first time, you'll be able to hear on the video. So going back to, talking about if you're designing software, say you run a car dealership, and you'll have software objects that represent each of your car. And those software objects need the same descriptions that your real world object contains. You'll need to, in your software, you'll need to keep track of what's the color, how many miles does it have, what's the miles per gallon, how many tires does it have? Maybe it's a motorcycle, things like that. So that's what an object is. And in Java and in most programming languages, we represent that with the concept of a class. You can think of a class as representing a real world object. And we'll do some examples here shortly. A class can represent that real world object. And a class can have what we call, well, the word variables. We've used the word variables many times before. But a class can have variables that represent those descriptive components. You can have a variable that represents the color. You can have a variable that represents the mileage. You can have a variable that represents how many gallons of gas it has. You can have a variable that represents the make and the model of the vehicle. And then that class, it will contain methods. And you saw methods from last week, but the class can contain methods that are the things that you can do with the car in this example. It's like the verbs. So you can have a method that drives the car. You can have a method that fills up the gas tank. You can have a method that computes the price of the vehicle, right? And those will all be contained within a class. So let's start looking at some code. And whether you know it or not, you've already been using classes. You've already been interacting with classes. You have not created your own class yet. Well, you kind of have, but not completely. But you've certainly been using classes. And if you look right here in your main, this is what everybody's main starts looking like. Right here is we have the word class. So our main is already a class. It doesn't have much stuff in it. And really all the assignments you've been doing so far, it's not so much representative of an object per se. We're really just kind of we're letting Java know where the program starts. That's really the purpose of your main class. And of course, I called mine main. You don't have to call it main. You can call it whatever you want. As you've seen with your assignments, I see most of your assignments, you name this something like assignment 1, assignment 2, or some people put their name there, which is all perfectly fine. For me, I just put main just because that's just what I picked at the time. All right. So even though this is a class, this is really just us defining to Java where our program starts. All right. But let's go ahead and start making our own class. Like I said, our theme here today, this morning, is going to be about a car. All right. So let's make a new software object, a new class that will represent a car. So here in my IDE, this is how I make a class. In your IDE, it's however you create a new file. If you're not using an IDE and you're just using Notepad, it's really the same thing. You're just making a new Java file. So I'm going to do new class. I'm going to call it car. And here I now have a car.java file right there. And it already made the beginning of it for me, a public class car. So car is the name of my class. you can think of this as kind of equivalent to an integer or a string or a float. This is kind of the type of the variable that I'm going to end up making. All right, so we have a car. So like I was saying, we need to have a description of the car, and we need to have actions for the car. Right. So the description is kind of what I was talking about, color, make, miles per gallon, how many gallons are in the gas tank, and so on and so forth. So we need to have some variables that represent and describe a car for us. So we'll have an integer that says how many miles the car has on it. Right. And it's just the int is exactly what you think it is. You've been doing this for 6 or 7 weeks now. It just means it's an integer. And that's the name of the variable. It's kind of standard that for classes, for the variables, you put _, in the name. It's not a requirement, and I'm not requiring you to do it. Just know that that's why I'm doing it, is because it's good practice to kind of start the variables like that. And what it stands for member. And it just helps you remember this is a member variable for this class. That's why I put the _, there. I'm not going to hold you to the same requirement. That's a little bit at the next level of class, should you end up taking it. But just so if you see me put that _, there, that's just what it means. It's really just part of the name. All right, so we have miles. What else describes a car? We'll have a string that says what color the car is. We'll have another string that says what make it is. We'll have another string that says what model it is. We'll have another integer that says how many gallons of gas it has right now. And let's do one more. We'll have a float that says what's the miles per gallon, right? So these are all variables that describe a car, right? That's half of the class right there. Now, certainly there are many more that describe a car. What engine size do you have? What color is the interior, what kind of stereo you have, et cetera, et cetera. There are a lot more that describe a car. And if you were making this as live software to be used actually in production at a car dealership, you would probably want to have all those other things. But to keep us from spending all day long on this is all the variables I'm going to use to describe a car, all those different things. All right, now let's think about things that we can do with a car. Well, we can drive the car, right? So we'll make a new method called drive. This is just like last week when you were making methods to, find the index of the highest score. Find the index of the lowest score. Those are methods you made last week. They were methods in that main class, but they were still methods. Likewise, we're going to make methods that are things that we can do with our car. So we can drive our car, right? We can fill up the gas tank with our car. And I'll explain in a minute what all the voids and stuff mean. We fill up our gas tank. What else can we do with the car? Let's say we want to compute the price of the car. If we're on a car dealership, we want to know how much that we want to sell a car for. We'll describe the internal. We'll do all the internals of each of these methods here in a minute. So compute the price, fill up the gas tank, drive it. That's enough for now. Let's kind of leave it there. And then there's one more special one, and it will be the same exact name as the class. So the name of the class is car, and there is a method that is the same name as the class. This right here is called the constructor. This function, this method is called every time you make a new car. and we'll see how to make a new car. Right now, let's just let's fill out some of these classes so we start seeing it in action, and then we'll slowly build upon it. So each time we use one of these methods, I'm just going to print out the name of the method so we know where it's at. So let's do a system out print line. We're in that method. This is the drive method. This is the fill up gas tank method. This is the compute price method. All right. So each time we use one of these classes, we're just going to print this out just so we can see where the flow of the code is. Okay. So far we have pretty much, not completely, but almost a complete class that is a car, and it describes what a car is, and it tells us stuff we can do with the car. So it's representing the real world object. This describes the object, and this is actions we can do with the object. Okay. A couple more things we want to do here with this class before we start using it. When we look at our description here, there's actually one more thing that needs to go on the front end here. And 99% of the time, it is the word private. Let me put it in front of all of them, and then I'll tell you what it's about. Okay, so we have this code block that's a car, right? I've talked about code blocks before, but for the class, the code block for the car starts right here at this bracket and ends down here at this last bracket. Right? Now, when we put private with these variables, that means they cannot be accessed outside of this class. So if I have code anywhere else in my program, meaning if I have code in my main, I cannot access these variables. And that's actually what we want. It may be a little counterintuitive, but it's actually what we want. And we'll get to describing why. Now, they can be accessed anywhere else inside of car. They can be accessed inside any of these methods. And the reason being is because these variables are inside of this car code block, and these methods are inside the same code block, so it can be accessed. But again, what private means is it cannot be accessed outside of car. And 99% of the times, that is exactly what you want. The alternative to that is if we would put public. If we would put public, it means that it can be accessed outside of the class. So if I was in main and I had a car, then I could directly access that miles. I couldn't access anything else because they're private. But if the miles is public, then I can access it outside the class. Even if I had 10 other Java files here, and all 10 of those Java files, I could access that public variable. But as I said, 99% of the time, you want them to be private. And the reason being is that these represent the internal state of the car. Okay? You usually don't want to be able to directly modify the internal state. You can interact with the car by doing these things. These are going to be how we interact with the car. You don't want people, or you don't want outside code directly interacting with your variables. And we're going to see a good example of that here in a second when we do the drive method. When we do the drive method, you'll see why that's very important to keep your internal variables all listed as private. But for completeness sake, there is also the word public that does allow you to access it outside the class. But there's almost never a good reason to do that. Private is what you want to use. Okay. Now the same thing applies to your methods. Your methods can be public or private. Generally, most of the time, you want your methods to be public because this is how we want the outside world to interact with our class. We want them to interact through our methods. So from our main here, it's outside of the car. We do want it to be able to drive the car. We do want it to fill up the gas tank. And we do want to be able to compute the price. But if for some reason you didn't want them to be able to fill up the gas tank, you can make it private. And then from outside the class, you would not be able to use that method. It would be like it's invisible. Now, internally, you could call that. So for some reason here in Drive, I wanted to fill up the gas tank, I could do that. That works internally to that class when it's private. Also, if it's public, you can also use the public ones here. That's fine. But from outside the class, you can only use what is public. And we're going to go ahead and make these public now because like 99% of the time, your variables will be private. 99% of the time, your methods will be public because this is how you want to allow interaction with your class, with your object. Okay, so we're going to go to main now, and we're going to do some interaction with this car object. And then we'll kind of come back here and we'll fill out these internal methods so that it actually does fill up the tank. So it actually does drive the car and compute the price and so on and so forth. So this is a complete class. It doesn't do anything useful yet because when I call the methods, all it's doing is just printing out. That's not very useful yet. We will make it useful here in a little bit. But for now, this is a complete class, and let's see how we want to use it. So in main, we can make a car, and we do it like this. We use the word car, just like we would use the word integer or float or string. You know, that's the type. The car is the type. And then we have the name of the variable. Let's call it my car. So that is making a variable. The type of the variable is car, which is the name of my class. And of course, the name of the variable is my car. Now, with integers, we could just do that. We could say int a, and then we could put, a equals 5, and that's fine. That's fine for integers. That's fine for your very basic types, like integers, floats, doubles, and strings. But for your classes, that's not enough. If we would do mycar.drive, that would actually crash my program right now. And the reason being is, unlike an integer, with an integer, you can do that. With a class, you have to make a new one. And what I mean by that is, I don't mean a new file, because we already have this Java file that does all the description of a car, or describes the car, and then describes what you can do with the car. But you make what we call a new instance of the car. And it looks like this. You'll have the type of car, the variable name, my car, and then you'll put equals new car, just like that. What that does is it creates an actual new car object and allows you to interact with it. You can think of the class as kind of just like a template or the description of what a car is. This does not make a new car. This just describes what a car is. This, it actually makes a new car. We now have a new car called my car that we can do stuff with. And what can we do with it? Let's get rid of this integer stuff. What can we do with the car? Well, if we look at the class, anything that's public, we can interact with. So we have what I said that was the constructor. We can drive the car, we can fill up the gas tank, and we can compute the price. Now, what we've done here, we've made this new car, and when we do the new car, and this, like I said, all this applies to not just a car, any kind of class object. When you do new and then the car, that calls the constructor for the class. So if we go back and look at the constructor is this method right here that has the same name as the class. So whenever you do a new car, what all the code inside of here is what gets executed. So let's see that. So we have our main where we make the new car. And if we look at that car constructor, this is the code that should get executed. And let's see if that's what gets printed out. Let's run it. As you see, there you go. It printed out that car and the brackets because, you know, that's what I said to do when you make a new car. Let's see what else we can do. We can drive it, we can fill up the gas tank, and we can compute the price. So let's do each of those. Let's take our my car and let's drive it. That's how we call them. We have the variable name, dot, and the name of the method. Let's fill up the gas tank, and then we'll also compute the price. So this calls the constructor. This does the drive method. This calls the fill up the gas tank, and this calls the compute price. So if I run this code now, it's going to execute the code inside each of those methods. And if we look at the code again, all we're doing is just printing it out so we know where it's at. Let's run it. Look at our main. Of course, there you go. So we did the car constructor and it prints out that car. We drove the car and it prints out the drive. We fill up the gas tank and that's what it prints out. And we compute the price and that's what it prints out. Now, calling these methods by themselves isn't what does printing. The printing is when it actually comes into the drive method, that's where I'm doing the printing. So for instance, if I just said, instead of printing drive, I just printed A, B, C, D. Then when it does drive, it's just going to print A, B, C, D. What it's printing out is not tied to the name of the method. And that just displays that. See, there is calling the constructor. There, that's calling the drive method because inside that method, I'm just printing out ABC and fill up the gas tank and compute the price. Okay. Like I said, this isn't too terribly useful yet. And I say that because whenever I drive, all I'm doing is printing something, right? But let's think about when you drive a car, what happens when you drive a car, right? What happens to the internal state, the description of the car? What changes in the description of the car when you drive it? Well, the number of miles goes up, right? Every time you drive your car 10 miles, your odometer increases by 10 miles, right? When you drive it, the color doesn't change, the make and the model doesn't change. How many gallons of gas you have in your car changes, right? Whenever you drive it. So whenever we drive our car, we need to change the internal state of the car so that it's still representative of the car. Let me take one step back from that for a second. So when we make a new car, what are all of these equal to initially? if we would print out each of these variables, what are they? Well, like I said, whenever you make a new car, that calls the constructor. So right here in the constructor, let's print out each one of those variables so that we know what is that variable equal to initially. So we got miles, we got color, we got make, we got model, we got gallons of gas, and we got MPG. There we go. So now whenever we call the constructor, I'm just going to get rid of the rest of these right now. So the only thing we have is the constructor. So what I'm going to do is I'm just going to print out all the variables so we can see what they're equal to. So when we run it, there you go. So the miles is 0. The color and make model are all null. And what null means, it just means there's no value. And it really applies to strings. You can see the color, make, and model are all strings. That just means it has no value. It's not the value 0. It means it is no value. But the miles is the number 0. The color, make, and the model are null. The gallons of gas is 0. The miles per gallon is 0. And the miles are 0. Now, is that realistic for a car? No, because a car is going to have a make and a model and a color. It's probably already going to have some miles on it. It's probably already going to have some gas in it. Oops, well, I printed out miles twice. Let's take one of them off. Right? It's already going to have some gallons of gas in it. It's going to have some kind of MPG rating, right? So let's set these to some initial values. Yeah, the question in the chat says the variables were automatically assigned the value of null or 0. And yes, that's correct. Whenever you make a new instance of a car, if you don't explicitly set their values, they will start off to be 0, or in the case of a string, it'll start off to be null. But that's not what we want, because the color of a car is not going to be null. It's going to have a color. The make of a car is not going to be null. It's going to have a make. The miles per gallon of a car is not 0. It's going to be, whatever number it's rated at. So we need to set these to some initial values that make sense. There's 2 ways you can do it. One is you can just manually assign them some hard-coded values. So let's just go in order. We could say the miles starts out at 1, 2, 3. And I'm just making these numbers up. There's no meaning behind them. We can say the color is red. The make is a Jeep. The model is a Wrangler. The gallons of gas it has 10 gallons of gas in it right now. And the MPG, Jeeps don't get good MPG, is 18.4. I don't know, something like that. Oops. I want to keep my print statements. So now if I run this code, I'm setting all the variable values to some value, and then I'm going to print them out. So now it makes a little bit more sense, right? This car has this many miles, that color, that make, that model, that much gas, and that's the miles per gallon for that car. Okay, that's one way you could do it, is explicitly setting each of their values like that. But here's the problem you run into. So we made one car here, right? How many cars are at a dealership waiting to be sold? Hundreds or 1,000 or more, right? Exactly, more than one. So we need to be able to represent more than one car, right? We can't just represent one car. There's more than one car for sale. Let's make another car. This is car 2. The type is car, the name of the variable is car two, and we will also make a new car out of it. So what's going to happen now? Now, whenever I run it, let's make this more descriptive. System.out.println. This will be the first car, so we can tell when the first car starts and when the second car starts when we're looking at our printout. All right, let's run it. So now there we go. See, there's our first car, and that's all the values for the first car. And now there's our second car that's absolutely identical. All right, let's do one more. Third time's a charm. Third time is a charm. Will it change? Will it be different? Run this. And nope, there's the first car, that same Jeep Wrangler, red, miles per gallon. Second car, identical. Third car, identical. Well, that's not too useful unless you have absolutely identical cars on your entire car lot at the car dealership, right? So we need a way to change or to differentiate between the cars. All of the cars do not meet this criteria, right? All of the cars are not red Jeep Wranglers with, all those numbers. Okay, so think back to last week to where you had methods, and those methods took explicit parameters. Last week, the parameter to the method was, I think it was the array, right? Yeah, it was the array of scores. You gave the array of scores as a parameter, and that way inside that method, you could use that array to do your computations, right? Well, it's similar here. In the constructor, we can give the constructor parameters. So what parameters should we give this constructor? Well, we should probably give it the parameters that describe the car. That way, we can have different kinds of cars. What I mean by that, let's just say if we have the make here. The parameter we give it is the make. So here, instead of saying the make is always Jeep, no matter what, well, the make can just be whatever the parameter is that you gave it. So in our car constructor, there is one parameter called make. And instead of putting Jeep here as like the hard-coded value to where every single car is a Jeep, we're going to say no. The make of this car is whatever the parameter you passed in. So now when we go back to our main where we're making our car, we have to give it that parameter. What are we giving it? We're going to give it the make, which is a string. So we'll make the first one a Jeep. The next one, we'll make it a Ford. And the last one, we'll make it a Chevy. All right. Actually, let's just cut it back down to 2 so we can cut down how much we're printing out. Less printout to look through. All right. So here we're going to make a car, and the make of that car is Jeep. Car 2, and the make of the car is a Ford. Now let's print it. Let's run it. And so we have a little bit of progress. So here's the first car, still that red Jeep Wrangler, but now it's a Jeep because I told it it was a Jeep. Here for the second car, most of the stuff is the same except the make is now Ford. And why? Because in the constructor, I told it the make is a Ford. It's not a Jeep anymore, it's a Ford. The rest of the stuff is still the same, but let's go fix that now. So instead of just the make, also we can give it the model. We can give it the color. We can give it the MPG. And that's as far as we'll go with the example. Just know that you could do it for the miles, and you could add on the gallons of gas. You can still do those, but we're going to stop right here for our example. So now what should each of these values be? So for the make, it's going to be whatever you gave it as a parameter. The model will be whatever you gave as a parameter for the model. The same thing for the color and the same thing for the miles per gallon. So the color is equal to the color you gave it as a parameter. The MPG is whatever you gave it as the MPG parameter. Now we still have two left over. We still have the miles and the gallons of gas. And for those, I'm just going to go ahead and put a 0 and a 10. For some reason, my dealership, all the cars start off at miles with 0, and they all have 10 gallons of gas in their tank. Now, there is nothing wrong with you adding those as additional parameters. And really, for the miles, it probably makes sense to add it as an additional parameter, because all the cars are going to have different amounts of starting miles on it due to test drives and things like that. But I'm just going to say on my car dealership, all the cars have 0 miles. All the cars start off with 10 gallons of gas. But at least for the make, the model, the color, and the miles per gallon, all the cars will have their own. So now that we've changed the constructor, now it takes these 4 parameters. Where we make the cars, we need to give it the additional information. So we're supposed to give it the make, then we're supposed to give it the model. What's next? We're supposed to give it the color, and then we're supposed to give it the miles per gallon. There we go. The same thing for our Ford down here. Model, let's say it's a Bronco, and the color is red, and it gets 5.5 gallons a mile, or miles per gallon. So now when we run it, there we go. We get our first car, and indeed, it is that white Jeep Wrangler. It has 10 gallons of gas in it. It has no miles, and it has that many miles per gallon. Our second car is this red Ford Bronco. No miles, 10 gallons of gas in it, and it gets 5.5 miles per gallon. Okay, so now we've made some progress with our class. We've made a way to differentiate between different instances of a car, and that's what this is. The actual class file itself just describes a car, and each time we make a new car, it's what we call an instance of the car. So this car is completely separate and different from this car. They're both completely independent from one another. Okay, so let's do something with these cars. For my car, let's drive it, and then we'll drive the second car. Okay, but right now the drive doesn't do much of anything useful, right? The drive just prints this out. It's not very useful. We're going to make something useful out of it in a second, but let's add one more method that will kind of ease how all these print statements. See, I have all these print statements. Let's make that a little bit easier for ourselves. And pretty much every single class will have this, and it's called toString. So it's a public method, which means what? It can be accessed outside the class. The return type is a string. So whatever work or computation is done in here, it will return a string. Just like when you did your assignment last week, you had the method to find the index in the array, and the return type was integer, and at the end of that method you returned a number. Same thing here. The return type is going to be a string. The name of it is toString. And what we want to do here, I'm going to create a string that kind of represents this car. And what I'm going to do in that string, I'm just going to put all of the variables, what their values are. We'll see how this is useful here in a second. So let's make a string. And what all variables do we have? We have let's do make model color. Say make is this dot make. And let's see, we'll do model. We're just making one string that is describing the car. Make model, what we got, color. And this will make our life very much easier here shortly when we start filling out all these other methods as far as compute price, fill up gas tank and drive, and so on and so forth. Color. Do MPG. What else do we got? We got make model color MPG, miles and gallons of gas. Miles. Let's see, in gallons. I think that's all. So after I make that string, I'm just going to return that string. Notice I'm not actually printing anything in here. I am right here, but we're actually going to get rid of those. I'm not printing this stuff in here. I'm just making a string that kind of represents all that, and I'm returning the string. Let's see how that's useful, and then we'll start filling in these other methods. So we got this toString. Like I said, very important. Notice I am not printing the string. That does not print a string. Returning it does not print it. But whenever I construct the car, and actually, I'm going to get rid of the rest of these prints. Prints are generally undesirable inside of classes. Java will let you do it. Java does not stop you from doing it. I'm talking about from a professional standpoint. Prints are generally undesirable inside of classes. All right, so we've gotten rid of all of our prints. In our constructor, we're still taking those parameters and assigning it appropriately. The rest of our methods still don't do anything yet, but our toString will make the string and it will return the string. Okay, so how do we use that? So here in our main, we are printing. We're printing out, here's the first car. We're constructing the first car. And now in our main, let's print out that car toString. And we'll do the same thing for car 2. So, you've seen the print many times before, the print ln, it will print whatever is inside of here, right? What is inside of here? Inside of here is my car.toString. So Java will execute whatever this is, whatever car.toString is, it'll start executing that. And what is it? It's this right here. It's the code. It'll make this string and then it will return the string. That's key. It returns the string. So ultimately, what this is equal to, the my car.toString, it is just a string. It's whatever it returns. So here, we're going to print out whatever that string for a car is. The same thing for car 2. Let's run this. There you go. So there's your first car. That's a lot easier to look at because we can actually see what the make, the model, color, miles per gallon, miles and gallons are, right? That looks pretty good. Okay, so that's our two-string method. Like I said, almost every single class will have a two-string method. And it's just a way for you to be able to construct a string that kind of represents what the internal state or the description of the car or whatever class that you're making. All right, now on to drive. As I mentioned earlier, when we drive a car, what actually changes about the car itself, right? If this is what describes a car, and like I said, I know there's many, many more, but we're trimming it down a little bit. When you drive a car, what actually happens to the car? What changes with the description of the car? Well, your miles will increase and your gallons will decrease, right? So when you drive, miles go up, gallons go down. All right. So let's make our miles go up whenever we drive a car. So let's say every time we drive, we just drive 10 miles. Okay. And every time we drive, it uses 3 gallons of gas, whatever. The 10 and 3, I just completely made up off the top of my head, just for example purposes. So every time we drive, we're driving exactly 10 miles. And every time we drive, we use 3 gallons of gas. Let's go back to our main and let's drive our car. Not so worried much about the second car anymore. Let's get rid of that. So what we'll do, let's put some comments in here. Make a car. We will print the car. Let's drive the car with car.drive. And then we will print the car again. The reason why I'm doing that is so that we are going to print the car before we do anything with it. And then we're going to drive the car. And then we're going to print the car again so that we can see what changed. What is supposed to change is when we drive the car, what changes? Miles go up, gallons go down. So when we print the before and after, we should see those changes reflected. Let's run it. There we go. Here's the before. You see we have 0 miles and 10 gallons. And here is the after. We now have 10 miles and 7 gallons. Miles did indeed increase by 10, and gallons did go down by 3. Why those specific numbers? Because we made the code that said that's exactly how many it does, right? Well, that's not very realistic though, is it? We don't always drive exactly 10 miles. We don't always use exactly 3 gallons of gas. No, it's an unknown. We drive an unknown number of miles, right? But for our car, it needs to know how many miles to drive. So just like with the constructor, when we have these parameters, our drive can have a parameter, and we'll have an integer num miles driven. So that our method, it will receive as a parameter how many miles that we drove the car. Now we can do a better computation, right? So if this is how many miles we drove, then our internal state will go up by that number of miles. That makes sense, right? Our gallons of gas, it should decrease a certain amount, but how much should it decrease? Should it decrease by the number of miles driven? No, that doesn't make sense, right? But we have something else here, the miles per gallon, right? That tells us how many miles we can go on each gallon of gas. So it's just a little bit of math here. So if we know how many miles we drove, we can compute the number of gallons of gas it should have used. I think that's right, right? Miles per gallon. Yeah, I think that's right. I think that's the right math to make that happen. I'm not in my math mode this morning. So when we drive, let's say our miles per gallon is 2, right? Some reason we only get 2 miles per gallon. If we drove 10 miles, then this would be 10 divided by 2, and that would give us 5 for 5 gallons. And that makes sense if you think about it. If we drive 10 miles and we get 2 miles per gallon, it takes 5 gallons to get there. So this math kind of checks out, right? So now whenever we drive, we're giving it a parameter, how many miles we drove. That's how many miles it goes up, and that's how much gallons of gas we use. So our miles go up, our gallons go down. Now let's go back main. So whenever we drive, we also have to tell it how many miles we want to drive. Let's say we drove 100 miles. Let's run it. And when we look at it, one thing I messed up. Everybody makes mistakes. One thing I messed up, and we'll see here in a second. So there's our car before, 0 miles and 10 gallons. And here's our car after, 100 miles and 4 gallons. Something's a little bit off with that. And what do we think it is? At least I think it is. Miles, gallons, 4 use 6. I think I may have accidentally did some integer math there. Did I do it wrong? What did I do wrong? This is exactly where you need test cases. Oh yeah, is gallons of gas? Oh, I'm sorry. No, that's what it is. See, gallons of gas is an integer. That's probably where I went wrong, right? Is whenever it did this computation here, it ends up with like a floating point number. It was probably like 4.5 or something like that. But because gallons of gas is an integer, then the answer always remains an integer. That's probably not what we want. So I made a mistake. Let's go back and change it. So instead of an integer, let's have a float, because you don't have to have exactly 4 gallons of gas. You can have 4.2 gallons of gas, 4.5 gallons of gas, 7.1 gallons of gas. So that's better represented by a float. Let's make the rest of these float that are with it. Yep, that should be fine. Now let's run it. And there we go. That looks better. So there's our car before, 0 miles, 10 gallons. And after we drive 100 miles, we're now at 100 miles and, that many gallons of gas. If we drive it again, let's drive it again. This time we only drive 30 miles. Well, 34 miles. And we'll print it out along the way and see how it changes. So here it is at the beginning with 0 miles and 10 gallons of gas in it. After we drive it 100 miles, it's at 100 miles with 4.5 gallons of gas. And then we drive it 34 more miles, and now we're at 134 miles, and we have this much gas in it. Okay. So this is how we have used a car. We have driven a car a certain number of miles, and it changes the software representation of that car. So you could think of this, like I said, if this is a piece of software that's running a car dealership, you give the keys to somebody and let them go out for a test drive. Well, initially, that was the representation of your car. It represented an actual physical car out on your car lot. And the car had no miles and that many gallons. So in the real world, you give the keys to somebody, let them go on a test drive. Let's say they drove it 100 miles. And so when you then put in your computer system, hey, they drove it 100 miles, then it changed the internal representation of your car. So the software representation of that physical object changed to this right here. And that could be useful, say, if you need to know how many gallons of gas all of your cars have, then you would probably add up all the gallons. You would go through all your cars. You would add up all their gallons of gas. And when I say this, I mean in your software. You would look at all the cars. You would add up their gallons of gas. And then you would know how many gallons of gas are in all your cars. And then maybe it helps you decide how much more gas you need to order. How much gas you need to have delivered. That's a real world example of where these classes are important, having software representation of real world objects, which this car is. All right, so that's our drive. Let's do some other stuff with our car. So what else can we do? We can fill up the gas tank. So when we fill up the gas tank, what changes with the internal state of the car? It doesn't change the miles. It doesn't change the color, make, model. It doesn't change the MPG, but it does change how many gallons of gas are in it, right? So with a fill up the gas tank, it will increase the number of gallons of gas in it. How much does it increase by? Does it increase by 1? Does it increase by 3.14? We have to tell it how many gallons of gas we put in it, right? So we'll have another parameter called gallons added. That's how many gallons of gas we put in the car. So the number of gallons in the car will increase. This is the action we're doing on the car. The parameter is whatever information that action needs. So if we fill up the gas tank, it needs to know, okay, well, how much gas did you put in it? And since this is how much gas we put in it, well, our internal representation increases by that much gas. Now, in the real world here, you would have to have some other checks in here to make sure that real world add checks to make sure didn't go over, like your gas tank limits. Like, your gas tank can hold 15 gallons or whatever. In a real software product, you'd have to make sure that, it doesn't increase over the actual limit of the gas tank. We're not going to go that deep into it this morning, but just some extra stuff to think about. Okay. So really, that should be all that changes about filling up the gas tank. So let's go back here. So we make a car, print the car, drive the car, print the car. Let's fill up the gas tank, fill up gas tank, and print it out again. My car, fill up the gas tank. We put 3.1 gallons of gas in it. And then we'll print it out again. Let's condense this down a little bit. There we go. Same thing. Make the car, print the car, drive the car, print the car, fill up the gas tank, and print the car so we can see the difference along the way. Let's run it. Here we go. So there is the original car. 0 miles, 10 gallons. We drive it 100 miles right there. So now it's at 100 miles with that much gas in it. Then we add 3.1 gallons to it. And notice the mileage stayed the same because we didn't drive it anywhere. We just filled up the gas tank. The mileage stayed the same. The number of the gallons went from about 4.5 to about 7.6. And that's accurate because we added 3.1. So that's fill up the gas tank. Okay, so that was good. And then the last one we're going to do is we're going to compute the price. Okay. And notice we don't have a price variable, right? We certainly could. We could add another variable in here for price. And for a car, that actually probably makes sense. But for example purposes, we're going to do some kind of mathematical computation to determine the price of the car. All right. So let's just say we're going to use a math equation to compute price of car. And I'm just completely making it up. I don't know. In the real world, I don't know how they price cars. But we're just going to make up a math equation to compute the price. We'll say the price will be equal to, let's see, less miles are generally good, right? So we'll say 1,000 minus miles times 500. Whatever, completely randomly made up. So for example, if we had 0 miles on it, then it'd be 1,000 minus 0, which is 1,000, and then 1,000 times 500. Ooh, 500,000. Maybe I should lower that down. Let's make it 50. 50,000, right? If they had 500 miles on it, then it would be 1,000 minus 500, which is 500. 500 times 50, 25 by 25,000, I think. I might be off by one number. But we're just going to use this math equation for the price. So let's actually compute it. The price will be equal to, I just said 1,000 minus how many miles it has, which is represented by the miles, times 50. And notice here, it returns a float. So instead of returning 0 for the price, let's return the price. So now let's use this compute price. And we go back to our main, we did all this, make, model, drive, fill the gas tank. Let's compute the price. And we can just print it directly. System.out.println. We'll do mycar.compute price. And we'll put a little description there, that's what the price is. And remember, the compute price, it returns a float. So Java treats this just like if it was a float. So I'm going to print out price plus whatever that float number is. Oops, wrong button. It'll work. And there we go. So, et cetera, et cetera, et cetera. We drove it. We filled up the gas tank. Here it is at the end. At the end, it has 100 miles on it right now. And that is the computed price. Is that correct? Well, I have a little calculator here. I'm going to make sure it's correct. So it has 100 miles. Let's look. This is where your test tables are very important, by the way. So if it has 100 miles, then we're going to take 1,000 minus 100, and that's 900, multiply it by 50, and I get 45,000. So that is the correct computed price. Of course, if we would drive it again, let's say we drive it 100 more miles and then print the price again. Because with my math computation, it relies directly on how many miles it has on it. So if I drive it a certain amount and then compute the price, if I drive it more and compute the price should be different. I think it should be 40,000. Let's run it. Yep, there we go. So this is the price after we drove 100 miles, and this is the price after we drove a total of 200 miles. Price keeps going down. One more little tweak to the car, and then I'll do a little bit of some touching up on some array type stuff. All right. So with a price, Let's add it here into the description of the car. Say price is this dot compute the price. That way, still, whenever we print out a car, it'll print out the price with it. And just to show you that, let's get rid of this extra stuff. We'll still just have to make the car, drive the car, fill up the gas tank. Demonstrate that. And there we go. So there it is, 0 miles, $50,000. Now it's at 100 miles and it's that price. And it's still at 100 miles, it's still at that price. So all that works. So that is a complete class. That's not too different than what you have to do for your assignment. One more quick time of the car. We call it a class. That's just saying this is an object. This is the name of it, the name of its car. All these variables are the description of the car. 99% of the time you want them to be private. 99% of the time you don't want them accessible outside the class. This is the constructor. This is what gets called whenever you make a new car. This is the code that gets executed. And then these are all the different things we can do with a car. We can drive it. We can fill up the gas tank. We can compute the price. And then the toString, it just gives us a string representation of what the car is. So that makes it easier to print out. Okay, I'm going to do a little bit of a rehash on the arrays because I had several people ask me if I could go over arrays again from last week. Okay, so for our car dealership, one car doesn't make sense. They have more than one car for sale, right? So maybe they have 2 cars. Maybe they have 3 cars. Maybe they have 4 cars. My car, 2, 3, 4. We'll call this one 1. All right. Maybe they have 4 cars for sale. Maybe they have 6 cars for sale. Maybe they have 10 cars for sale. Maybe they have 1,000 cars for sale. Does anybody want to sit here and wait for me to go through and type this in 1,000 times? Probably not, right? So the better way to manage that is with an array. An array is just a single variable that allows you to have multiple instances of that type of variable. You know, for your assignment last week, you did it with, I think it was integers, right? You had int, whatever, bracket equals new int. Let's say you had 10 of them, right? This allows you to have 10 integers so that you could access them like this. The 0, 1 is equal to 3. The 1 is equal to 5. The 2 is equal to 6, so on and so forth, right? So I did not have to do A1, A2, A3, all the way up to 10. I can make one variable that is an array, and the brackets is what says it's an array. And then I have to make a new array, and this is how many things are in it. This is saying there's 10 things in that array. So I can start at 0 and I can go all the way up to 9. And the reason why that is that actually is 10 items. Let's see, 3. Let's make this shorter for demonstration purposes. Let's say it goes up to 4. And we'll stop right there. The highest one that you can access is 1 minus, or excuse me, how many ever you made minus 1. So that means we can only go up to 3. There are still 4 items in there, right? That's 1, 2, 3, 4. It's just because the counting starts at 0, That's why the last one is the size minus 1. So the last one is the third index. All right. That's how we did it with integers. With cars, it's really not any different. So instead of integer, it's going to be a car. You can still name it A. I don't care what you name it. You can leave it as A. You still have the brackets, meaning it's an array, but instead of a new integer, it's new car. So now we have make an array of 4 cars. So we have these 4 cars, right? Let's print out each car. Let's delete that. So we can delete all this stuff down here now. Let's print out each car. We're going to make a loop that prints out each car. You've all seen loops before. System.out. If this doesn't look familiar to you or you're not sure, let me know. But you've all done loops before, and you've all done, well, you've done the arrays from last week. So this is just making a loop, starts at 0 and goes until the length of the array, and then it just goes up by 1 each loop. And so A at index I, so the first time in the loop, I is 0. The next time in the loop, it's 1. The next time it's 2. The next time it's 3, so on and so forth. So actually, let's actually print out what I is as well. So we're going to print out I, and then the toString, that toString method of the car. So A at index I, it is one of the cars, right? This array A, it's an array of cars. So each individual one is a car. And just like we did the car.toString earlier, this is that one individual item toString. And that individual item is the car. Let's run that. And we actually get a crash. I knew the crash was going to happen, but why do we get a crash? Because what is system.out.println? What is A of 0? Let's print them out like this. A0, A1, A2, A3. Let's do it without the loop. So what is A of 0 right now? Each one of those is null. And that's because we've created an array of car, but we still have not yet created each individual car in that array. So at index 0, it's a car, but the car doesn't exist yet. You actually have to make the car. You can make it like this. A at index 0 is a new car. And then what all you got to put? You got to put the make, Jeep, Wrangler, white, and it gets 10 miles per gallon. I don't know. So now when we print them all out, now it kind of works. You know, there's the first one, and then the other 3 are still null. A1, A2, A3 are all still null. So let's make the other ones. All right, A1, 2, 3, and I'm just going to make this. I don't want to make up car names all day. We'll just put that as the make, or excuse me, as the model, so we can differentiate between them. So we made an array of the cars, and then for each car, we made a new car at that index. So now when we go through and print, now whenever we access it, there is actually a car there. Run it. And there you go. We have 0, which remember we we printed out the I colon and then the car. So there we go. At 0, it's, this right here, this Jeep but model A0. At index 1, it's model A1. And that makes sense because here at index 1, the model is A1. Index 2, model A2, and index 3, model A3. All right. So that's how you can make an array and hold multiple cars in the array. And that's much more useful for a dealership if you had, say, 10,000 cars. Now, instead of manually creating each of those 10,000 like this, I'm sure they would have some kind of software that would load it from a database or something like that. In their computer code, they wouldn't create them like this. It would be something like A at index 1 equals read some info from a database. However they implement that, that's significantly more complex topic than what this course covers. But they would read it from a database instead of just manually creating it like this. But the concept still remains the same. All right, let's make one method dealing with this array, and then we'll wrap it up. So let's change these miles per gallon a little bit so we can differentiate between the Jeeps. So let's say we have a method and we want to know which car at the dealership gets the best gas mileage. All right, so let's make a method. Really, it can be public or private here because really there's nothing going to exist outside of our main that's going to use it. So let's just make it private anyway. Remember, private means it cannot be accessed outside of the class, and that's fine because we're only going to use this inside the class anyway. So make it private. So let me make a comment first so we know what we're doing. We want to return the car with the best gas mileage. Is that right? That's right. So it's going to be private. So we're not going to access this method outside the class. It tells me what it returns. It's going to return the car. So the return type has to be a car. Then we put the name of the method. The name of the method can be anything you want it to be. But it's much more useful to name it something descriptive of what it does. I want to say find car with best gas mileage. Yeah, it's a little long, but at least it is very descriptive of what the method is going to do. Now, for parameters, what does this function need to know? What does this method need to know in order to find the car with the best gas mileage? Well, it needs to know what the cars are. So it needs that car array. So this is an array of cars. The type is car, and the name of the variable is cars. So now we need to go through this array and find the car with the best gas mileage. And that algorithm kind of looks like this. We can say this car is going to represent the one with the best. Let's say at the beginning, the first car has the best gas mileage. First car starts out being the best, right? Now we need to look through all of the other cars to see, does it have a better gas mileage? So let's make a loop to look at the rest of the cars. So we'll have 4 and we can start out at 1. We'll see why in here in a second. I less than cars.length. Oops. Loop through the rest of the cars. right? So when we're looking at the car array, why can we start at 1? Why don't we start at 0? And the reason being is we already checked 0. We kind of already checked 0, and we said the first car at index 0, it's the best car so far. But we haven't looked at any other cars yet, so the first one has to be the best. So you can imagine if you went to a car dealership and you were looking for the best car, if you had not looked at any cars yet, then that means the first one you look at is already the best one you've looked at so far. That's the same concept here. The first car that you look at is the best that you have seen so far. But now let's look at the rest of the cars. So we can say if the cars at index I is greater than that car. There's a red squiggly, and we'll see why here in a second. So if this new car we're looking at is greater than the existing car, then the existing car is equal to the new one. So we looked at the next car and it was better. The next car was better. So now the best was equal to the new one. Maybe that can help you visualize it better. We'll call this best. So if the one we're looking at right now is greater than the best, then the best is equal to the new one. And then at the very end, we want to return the best car. So now, why the red squiggly line? My IDE is smart enough to tell me there's an error right here. And actually, if I try to compile it, it's going to give me an error. Yep, see, tells me that there's an error. And the error is right here at this red squiggly line. So what does car greater than car mean? Are we talking about make? Or are we talking about Ford versus Chevy or something? Are we talking about the color of the car? Are we talking about how many miles the car has on it? Are we talking about what the miles per gallon of the car is? That's what we want to talk about. We want to compare their miles per gallon because we want to get the car with the best gas mileage. So this is just the car itself. This is not the miles per gallon. This is the car. We need to somehow specify that I want it to compare the miles per gallon. In order to do that, we need to know what the miles per gallon for each car is. So I could do, well, what I can't do is .mpg. Why can't I do that? Well, if we look at a car, there is indeed a variable called m_mpg, right? That represents what the miles per gallon is, but we can't use that here. And why? If we look at it, it's going to tell us it has private access, meaning because this variable is private, we cannot access it from outside the class. There's two solutions to that. One is we can make it public. Now, if we look here and we are comparing the MPG, that technically works. If I compile this, it would work. And let's show you. So, all right, we have these 4 cars. Let's find the best car is equal to the car. Sorry. In main, generally, your methods have to be static. Beyond the scope of this class, just know that. So find the car with the best gas mileage, cars, and the name of the array is A. And then we'll print out the best one. Print best toString. There we go. So this will actually work. So we make our 4-car array. Then we're going to call the method find the car with the best gas mileage. And we give it that array of cars. So it comes down here and it does this computation. it compares the cars miles per gallon to each other, and then it ends up returning the best. And here we're just going to print out what that best is. So if we do this, we should get this A3 right here, right? Because if we look at the miles per gallon, it has the highest. When we run it, oh, I think something broke on my IDE. That's unfortunate. Oh, let me start it real fast. I think something went wrong with my IDE. Until J. Give me a second for it to start up. Hopefully it resolves whatever problem this is. All right, let's try to run it. Please work. It's thinking for a second. There we go. Yeah, some kind of error with my IDE. All right, so now, again, we made this array of cars. This one right here has the best gas mileage. We can see that. And so now when we run the program to find the best gas mileage and we print it out, we can see the best is the A3, right? But this is definitely less than optimal. What's less than optimal about it is here, where we're using this internal variable of the class. This is generally bad business having a variable public. Why is that? What stops me from saying cars of I.mpg equals this? There's nothing that stops me from at any time, I could directly change what that variable is. So now when I run it, well, it says right there, it actually turned it into an exponent, 5.5 times 10 to the 7th power. Let's make it shorter so it doesn't do that. Make the variable more plain. There you go. So it's saying, well, A1 has this many miles per gallon to it, but that's not accurate anymore, right? Whenever I made this Jeep, I said it had 11 miles per gallon, but now for some reason it says this. That's wrong. What's happening is when you make this public, you allow anybody, any other code, anywhere else in the entire program to modify the internal state of your class. And you don't want that. You don't want any other code to just be able to change the internal state of the class. Well, okay, if we can't do that, then how do we do this? You can have what we call a getter method. The getter method is it can return to you what the internal state is. It doesn't let you modify it, but it can at least get you the value of it. So if we want to know what the miles per gallon is, let's just add a new method to get the MPG. And here we can just return MPG. So that will allow you to get the value, but it does not allow you to change the value. You can't modify it. So here, let's go back up here and make this private again. Make the MPG private again. So now we can just get the miles per gallon. Get the miles per gallon. And now if we run it, everything's all happy again. That's right. It's A3 with 13 miles per gallon. And so we cannot do this now. We can't get miles per gallon equals something. Doesn't work like that. This just gets the value back. It doesn't allow you to change the value. That doesn't work. So that's how you would use the arrays. If we want to, let's make it more closely aligned with what your assignment was last week. So for your assignment, in your methods last week, I was not asking you to get the actual score. I was asking you to get the index that had the best score, right? So instead of returning the car with the best gas mileage, let's return the index of the car with the best gas mileage. Okay. So we'll start off, first car starts off being the best, but now instead of finding the car, the best is just a number. It's the index. It's the same exact concept though. So the best starts out being the car at index 0. We're going to go through the rest of the cars. So now we're going to say if the car at I, MPG, but best is an integer, it's the index, but it's the index in your best array. And now, if this one is greater than your best, then the best isn't the car itself, the best is that index. And instead of returning a car, we want to return the index, which is an integer. So it's almost the same concept, not too much of this changed, except instead of returning the car, we are returning the index where that car is located. And so when we come back up here, it's returning an integer now. So it's returning an integer. So best is an integer. So let's print it out. So now best is now 3. That means it's the car at index 3 that has the best gas mileage. And that's right. It's right there. Let's change this to 22. It should give us a different answer. It should tell us that 2 is the correct index. And that's right. So what you can do with that now that you know the best, now you can do stuff with it. So we know in the car array at index best is the best car. So we can still know which car it is by using that index in the car array. And there you go. There it is. All right. So that is all of the materials on classes, object-oriented programming. Just kind of the key takeaway, and then I'll open it for questions after this. This is what a complete car class looks like, or any class in general, but this one specifically is a car. Public class means it's a class. The car is the name of the class. Take note that the name of the class must match the name of the file. So the name of the file that this in is car.java. So the name of the class has to be car. If I name this something else, does not work. Get squiggly here, get the red squiggly there underneath the file name, get red squigglies all over the place. And it's not just the IDE. If you were just doing this from the command line and you try to compile it, it would not compile. It would give you an error. The name of the class must match the name of the file, right? Then for all of the variables, they describe your object. This is what describes a car. Certainly, there are many, many more. But for our example this morning, this is what describes a car. 99% of the time, they should be private. If you have public here, you've very likely done something wrong. If you need to know the value of it outside the class, you can use something like this get method, where it can get the value, but it does not allow you to modify the value. There are extremely rare circumstances where public is useful, certainly not for this class. So your variables should all be private. And that means they can only be accessed inside of this class. This is your constructor. Constructor has the same name as the class. They're both called car. These are the parameters to it. This is what differentiates one car from another. And then we're just going to say the internal values are equal to whatever the parameters are. Oh, I didn't mention this earlier. That's what this is. This is not explicitly required. Style-wise and professional-wise, it is highly desired because I'm explicitly saying it's one of the internal variables. So whenever I say this dot variable name, you know I'm explicitly talking about this one. Where this can get you into trouble, let's say you didn't have the ilm there and you just had make. And you didn't have this there. What if you just had this? So you have an internal variable named make and you have a parameter called make. Java will compile this. But what's going to happen is if it's just make by itself, it's going to assume it's talking about this one. So it's just going to say this variable is equal to itself. It's not taking care of this one. It's using only this one right here because they share the same exact name. What you can do, if you put this in front of it, this dot, now you're explicitly saying, you know, I know they have the same name, but I'm explicitly talking about this internal variable, this one right here. It's best business to have a different name and using this. But if you did not put this, as long as they have different names, it would work fine. But style-wise and professional programming-wise, you want to use this generally every time so that if somebody is reading your code, they explicitly know you're talking about one of the internal variables. All right. So, and that does not apply just to the constructor. You see, I've done it with the drive, and I've done it with the fill up the gas tank, and I've done it with the price and the toString. I'm explicitly saying these are the internal variables. Ooh, this has gone on a long time, so I'm going to go ahead and wrap it up. And there's the same thing with the drive, fill up the gas tank, and so on and so forth. So that's all there is to a class, object-oriented programming. There are ways in your future programming careers and future programming classes where classes do get significantly more complicated. But at the basic Java level, this is what you need to know. All right. And as far as your final project goes, everything I talked about today is directly relatable to what is in your final assignment. All right. So I will go ahead and open it up for any questions. It can be about this assignment or any previous assignment or really anything about Java or the class in general. So the floor is open. All right, you have a good weekend too. Don't hear anything yet. I'll stick by about 1 more minute if there's any questions. If not, you can go ahead and drop off whenever you want. As always, I will get this video posted up online. If I don't get it in the next few hours, it'll definitely be before the end of the night. And have a good weekend, everyone.